Hi Math 30s. This video is going to be on lesson 8 and I'm going to be doing the last 3 class examples, so class examples 6, 7, and 8. Starting with class example 6, what it says is it gives us a graph, a sinusoidal function, and it says it wants the equation of this graph. So I'm given a few key pieces of information here. First piece of information I'm given is that this is a sine graph. So it's important that I know that it's a sine graph because what I always do when I deal with sine graphs is I say, okay, what does the graph of y is equal to the sine of x look like before it undergoes any transformations? So that's sort of where I always start. And then I say, according to this, there's two parameters or two transformations that have happened. So there's going to be an A value, so my graph is going to undergo a stretch, and there's going to be a C value, which is a phase shift. So I'm going to need to figure out both of these. Before I start this, like I said, I always start by sketching what the graph of y is equal to sine of x is. So sine of x always starts at 0. And this is what the graph of y is equal to the sine of x would look like. And there's a few key things about this graph. The maximum is 1. The minimum is -1. The intercepts, this would be pi. This would be 2 pi. So one complete period in a sine graph is 2 pi. And then the last thing that's really important to see about the sine graph, if I said, well, what's the midline? What's the middle of the graph? The midline is at y is equal to 0. Okay, so that's going to be your midline. Because remember that the midline comes from the d value, and if a d value is not written, my midline is going to be 0. Okay, so a few things. Going up to here, if I said, is there a d value on here? There isn't a d value, right? So that would be plus 0. So what that means is where I have this line here, that's my midline, and the equation of that line is y is equal to 0. Okay, so from there, we know that this is the regular sine graph. Let's look at what the stretch was, and let's figure out what the phase shift was for this graph. Okay, so the stretch is your A value, which is the amplitude of the graph, and that's the distance from the midline to the peak of the graph. So some of you would be able to just look at this and say, well, if that's my midline, this is at 4, my A value is equal to 4, and you'd be correct. The amplitude of this graph is 4. If you're ever unsure of the amplitude, you could use the formula. You have to memorize this formula, but the A value is the max minus the min divided by 2. So if I was going to use this formula, the A value would be the max of this graph is at 4, minus the min of this graph is -4. And you take that number and you divide it by 2. So 4 minus -4 is 4 plus 4, which is 8, divided by 2. The A value, or the amplitude of my graph, is 4. Okay, so that's the first thing. We just figured out that parameter there. From the A value, we now need to figure out what the phase shift was. So before we figure out the phase shift, always figure out what one box represents, or one hatch mark on your grid. So how you do that is they will always give you pi or 2 pi, right? So right here, they give me pi. So ask yourself, how many boxes do you have to count to starting at 0 until you get to pi? So if we start at 0, the number of boxes that we would get to would be 1, 2, 3, 4, 5, 6. So to get to pi, we count 6 boxes. Therefore, one box is going to be pi over 6, is what one box will represent. And you could double check that. If one box is pi over 6, so let's check. Here's 1 pi over 6, 2 pi over 6. This guy is 3 pi over 6. 3 pi over 6 reduces to pi over 2. 4 pi over 6, 5 pi over 6. This guy would be 6 pi over 6, which reduces to pi. So I figured out the scale factor, and the scale factor, one box represents pi over 6. Once you have an understanding of that, and you understand the stretch, what we're going to do is we're going to look at the phase shift. So remember that in graphs, we always do stretches first, reflections second, and translations last. The A value is greater than 0, so there is no reflection. Okay, so this graph does not have a reflection. It has a stretch of 4 and a translation. So what I want to show you is I'm going to show you where the graph would be after the stretch of 4. So I'm just going to highlight this graph for a second. And we know that this graph starts at 0. So I'm going to move this sine graph back to 0. So this would be the graph after the stretch, right? So after the stretch, it went from 1 up to 4. Then what you need to look at is you need to say, okay, well, what was the phase shift? So we start at 0, 0, and we're going to end here. What is my C value? Well, each box is worth, we said pi over 6. So this would be 1 pi over 6, 2 pi over 6. So my C value is 2 pi over 6, which reduces to pi over 3. This moved pi over 3 units to the right. So how we would show that is we would say, okay, y is equal to a, which is 4, sine. Because I'm moving to the right, my C value is positive. That is x minus pi over 3. From A, I'm going to skip B because B involves a reflection. So B is actually going to be like a standard of excellence question, B and D. A and C would not be standard of excellence. Like the majority of students should be able to do A and C. And then after I do C, I will go back and we will do B and D. Okay, so let's do C. So what it says is it says for this one, it is a cos graph and there's a stretch and a horizontal phase shift. So quickly write down what the graph of y is equal to cos of x would look like. So what does the graph of y is equal to cos of x look like? We know that a cos x goes from 1 to -1, just like a sine graph, but it actually starts at 1. Sine graph always starts at 0, cos graph always starts at 1. So on this graph here, it has no midline, or sorry, not no midline. The midline would be 0, okay? So the amplitude of this graph from the midline to get to the peak would be 4 units. So A would be 4. From there, we need to say, okay, what is one box worth? So one box, we'll just double check. But if we get to pi to get to there, I count 1, 2, 3, 4, 5, 6 boxes to get to pi. So each box is worth pi over 6. So my scale factor is going to be pi over 6. Okay, so now that we have the amplitude, we have to figure out the phase shift. So the phase shift is the one that you have to give it a bit of thought. I'm going to trace the cos graph. So it looks something like this. And remember that after the stretch, so it undergoes a stretch first, then it undergoes a translation. So this would be the graph, this graph here, my original cos graph, after I stretch it up to 4, after I apply a vertical stretch of 4. This is what my graph would look like. With a cos graph, to figure out the phase shift, you go peak to peak, okay? So for a cos graph, this would be the original, and this would be the translation. So with a sine graph, we want to go from the midline, right? So from the sine graph, we're going from the midline and we're staying on the midline. That's the phase shift for a sine graph. For a cos graph, we are looking at the original peak of this cos graph was right here. And then where did I move it? So the phase shift was from here to here. So now we have to count our boxes if each box is worth pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So my C value is pi over 6, or sorry, 5 pi over 6. And my phase shift, my horizontal phase shift, was 5 pi over 6 units to the right. That was what my phase shift was. And then once I move this 5 pi over 6 to the right, that's my translated graph. I've done my stretch and my horizontal phase shift. So now I have to put this into the equation. So the equation is y is equal to a is 4, cos of x minus 5 pi over 6, because I am going to the right and I want my c value to be positive. So that's how you do this question. Okay, let's look at B and D. B and D, like I said, these would be more standard of excellence because there's a reflection that's been involved. Okay, so this, we're back to our sine graph. And remember that our sine graph started at 0 and it went through to pi, and then this would be 2 pi. That's our sine graph. If we are following stretches, then reflections, then translations, here's what we would have to do. We know that our stretch is 4. So our A value is equal to 4. So that's what our stretch is. If, though, they want A to actually be less than 0, my A value will be -4, but the vertical stretch is still a stretch factor of 4. So remember, it's always the absolute value of A. So my amplitude is 4, so that doesn't change, right? So let's write that down. Amplitude is equal to 4. Because they want A to be less than 0, there's going to be a reflection. So I have to write that as -4. So I'm just going to write my amplitude is 4. My A value, though, is -4. Okay, because that's going to be the reflection. So now to show you the reflection, here's what I have to do. This is the original graph. And I need to take that original graph. So it's undergone the stretch, right? So the stretch of 4, my y values were multiplied by 4. So that's what the graph would look like. And then after the stretch, what do we do next to it? We undergo a reflection. So what you have to sort of imagine is I'm going to take this and we have to reflect it. So I'm going to flip this graph. This is what the reflection would look like. And then what you have to do is we have to match up the graph. So you have to say, do I move my graph in this direction? Or do I move my graph to match it up over here? And you always do what's called the minimum phase shift. So after my reflection, the minimum phase shift, and remember for a sine graph, I said you always go from the midline. So the midline's at 0. I could go, each box we said was pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is how I would count to get to there. So I would count up 4 boxes. Versus the other way, it would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6, 7 pi over 6, 8 pi over 6 to get over here. So I wouldn't go that direction. We want to go the minimum phase shift, which would be to the left here. So 1, 2, 3, 4 pi over 6. So my C value is equal to -4 pi over 6, which reduces to -2 pi over 3. That would be my C value. After it undergoes a reflection, I have to figure out how to get this point, which was the original, to the minimum phase shift, which would be -2 pi over 3. So how you would write that equation is it would be y is equal to the A value, which is -4 because it's a reflection, sine x. I want c to be negative 2 pi over 3. So I say x plus 2 pi over 3. And that would be your graph after it undergoes a stretch, a reflection, and then a translation. So let's look at the cos graph now for D. So cos graph of D. So again, remember that an original cos graph always goes from 1 to negative 1. So this is an original cos graph, okay? If I look at this cos graph here, I need to figure out what the amplitude is. So the amplitude from the midline up to the peak is 4 units. So the amplitude of this graph is equal to 4 units. But then what they tell you is they say they want A to be less than 0. So yes, the amplitude is 4, but the A value, if they want it less than 0, they're telling you they want it to undergo a reflection. So the A value will be negative 4. Okay, so we've got our A value. Now we have to, according to transformations, we do our stretches first. So we just did our stretch, right? So our stretch was 4, the y values are multiplied by 4. Then we're going to reflect this graph, and then we're going to figure out what the phase shift is. So the stretch is done. So here's my cos graph after the stretch. So what I'm going to do is I'm going to put this back to where it would originally be, would be here. And then after it undergoes a stretch of 4, this is what the cos graph would look like. Then they tell me that A is less than 0. So now I have to take care of the reflection. That would be the second thing I have to do. So to reflect this graph, I have to flip it. So that would be the reflection of my graph. And now with a cos graph, you go peak to peak. So with a sine graph, you're doing, so a sine graph, you're always working on the midline to do your phase shift. With a cos graph, you're always looking at the peaks. So this is a cos graph, so I'm looking at my peak. So my original graph is right here, and I need to move it to get to there, right? So my original graph, this is my phase shift. Or you could look at this one and you could say this point down here needs to go to this point down here. You're just looking for phase shift peak to peak if it's a cos graph. So I'm only moving one box, and one box we said was pi over 6. I'm moving one box to the left, so my C value is equal to negative pi over 6, because I am going pi over 6, a horizontal phase shift of pi over 6 units to the left. Now I need to combine these two into my equation. Y is equal to negative 4 cos x plus pi over 6. Okay, let's look at lesson 7, or sorry, class example 7. So we will do A and B. And then we are going to do, again, A is greater than 0 is what most students should be able to do easily. And A is less than 0 is where it becomes a challenge because you're doing a reflection as well. Okay, so this graph here, where I always start with this graph is let's actually start figuring out what one box represents. So what's the scale factor that they're going to use? Here's where pi is. Count up how many boxes we need to get to pi, and then you're going to divide pi by that number of boxes. So 1, 2, 3 boxes to get to pi. So our scale factor is going to be pi over 3. Okay, after I do that, where I start is I always start finding the D value. So this is where I'm going to start on the graph. So I'm going to find the vertical displacement. The formula to find the d value, it's going to be max plus min divided by 2. The max of this graph is 1. The min of this graph is -5. And you're going to divide that number by 2. That would be -4 over 2. My d value is -2. So originally, our sine graphs or cosine graphs are, there's no, d is at 0. But now my midline, so this is my midline, it's moving down to -2. So you take out a red pen and put in the midline at -2. Okay? From here, you could say, what's the amplitude of the graph? So the amplitude, you're going from -2 to 1. So once you have the midline in, a lot of students don't need to use the formula for amplitude. A lot of students can just look at this graph and say, well, how many units am I counting up? That would be 1, that would be 2, that would be 3 units. So the amplitude of this graph is going to be 3. So that's the second thing. Once I got my midline in, I always do my amplitude. If you wanted to double check using the formula, what was the formula for amplitude? Amplitude was max minus min divided by 2. So the maximum value of this graph was 1, minus the minimum value is -5, divided by 2. 1 plus 5 is 6, divided by 2 gives me an amplitude of 3 units. So you could either look at the graph again, or you could say, you could do your formula. So once I figure out what I always do vertical displacement first, I do amplitude second. The third thing that I calculate is the period. For period, I find on sine and cosine graphs, it's easiest to go from peak to peak. Even though they tell me this is a sine graph, I'm going to figure out the period by going peak to peak. So what I'm going to do is I'm going to count the number of boxes, and I know each box is worth pi over 3. Okay, so let's count the number of boxes. To get from this peak to this peak, how many boxes do we count? So I start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 total boxes. Each box, I said, is worth pi over 3. And this would be 12 pi over 3, which is equal to 4 pi. So my period is this here, which is 4 pi's. That's what my period is. Once you calculate period, say to yourself, what is period attached to? Like which parameter is period attached to? And it's attached to the b parameter. So once I have period, I'm going to figure out what b is. So we know that the formula is going to be period is equal to 2 pi divided by b. B is equal to 2 pi over your period. B is equal to 2 pi. The period was 4 pi. Pi over pi will cancel. B is 2 over 4, which reduces to 1/2. So my B value, I'm just going to write slash, my B value is 1/2. Because when I actually write the equation, I need to know what A, B, C, and D are. Okay, now that I have my period in there and my B value, let's go ahead and figure out what the phase shift is. This is a sine graph. What you must remember for a sine graph is when you're figuring out the phase shift, so let's write this down, phase shift, you work from your midline. Okay, so my midline, My original sine graph starts at 0. And then it moved now over to here. So my original sine graph was at 0, right? The sine graph, if you need to jot down, well, what was the sine graph? So sine graph, it always is on the axes, right? It's always on this axis here. So then you go to you find your axes at the midline, put a dot, and what's the shift that you needed to get to over there? And that shift is 1 box, and we said 1 box was pi over 3. So my C value is negative pi over 3. Okay, so the equation of this line is y is equal to a is 3. So it's 3 sine. Then we want our b value. Our b value is 1/2. And then x, either minus my c value or plus my c value. If I want c to be negative pi over 3, it would be x plus pi over 3. And then I do my midline at the end, and my midline is minus 2. So that is the equation of your line. Here's what we have to do to get this guy. A is less than 0. What that means is the following. If we undergo SRT, our stretch was 3. But because it's less than 0, our A value is negative 3. So it's going to undergo a stretch, it's going to undergo a reflection, and then I'm actually going to have a brand new translation. So what we have to figure out is our translation. So here's what happens. Our new equation is going to be y is equal to, the 3 trades with negative 3, sine. None of this is going to change so far. My C value will change, and my D value will not. So again, when A is less than 0, it means that this 3 is now negative 3, but it means my graph underwent a reflection. So here's what I have to do. I have to find my original graph. So my original graph, after the stretch, was this here. Okay, so what I'm going to do is I'm going to move this so that you could visualize this. I'm going to move this to here. So after the stretch, this is what my graph would have looked like. Okay, what I need to do is I need to reflect this. So you need to imagine all of these points reflected in your x-axis. So I'm going to take this and I'm going to flip this. This would be my new graph. Sorry, this would be my new graph after the flip. Then we have to say, okay, I now have to figure out what was my phase shift. So this graph, now I have to translate this graph in order for it to match up. So from the midline, we always figure out if it's a sine graph. It's always going to be from your midline. Where we started was right here. To match up my graph, I have to move it to here, right? So again, to show you that one more time, after my flip, this is what my graph looks like. Now I have to move it, translate it, horizontal phase shift, and I've got to move it there. So you have to figure out how many, what would that C value be? So each box is worth pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So what the new phase shift would be, it would be x minus 5 pi over 3. Okay, let's do C together. So again, C, the first one, everybody should be able to do. And then standard of excellence involves the reflection. Okay, so what it says for this is it says we are dealing with a cosine graph. So dealing with a cosine graph, I always say, okay, what's the original graph look like? And the original graph for cosine always goes from 1 to -1. Just like with A, what we want to do for this is I always start with my vertical displacement. Okay? And your vertical displacement is going to be the exact same as up here. So here's your formula for vertical displacement, max plus min divided by 2. If you do that for this graph, max plus the min divided by 2, you're going to get the same d value. D is equal to -2. So once you figure out what your d value is, get a red pen and a ruler, and you put in your midline. So the midline is crucial. The midline is crucial because it helps us see the amplitude. So after I figure out the vertical displacement, I go to amplitude next. From the midline, I would count 1, 2, 3 units. So my amplitude is going to be equal to 3. So again, always from your midline. You could use your formula for amplitude to verify that, but that's what it would be. Okay, the period. So again, period we normally count from peak to peak, or for these graphs I always count from peak to peak, and the period is going to be the exact same as above. We would have 12 boxes and each box was worth pi over 3. So my period doesn't change. It is going to be 4 pi. And my b value, we calculated it above. My b value is going to be 1/2. So all of this is the same. What we need to think about now is what is the phase shift. So the phase shift is the one that students have to sort of think the most about. My original graph, so if I trace this, you say, okay, the original graph after the stretch was here. When you're doing it for a cos graph, you always want to look at the peaks or the minimums, the maximums or the minimums. So the phase shift for this graph, for this cos graph, we started here and we're ending here. That's our phase shift. How many boxes did you count? So this is 1, 2 boxes. Each box is worth pi over 3. So my phase shift, again, if I was counting up the phase shift, would be from here to here would be 1 pi over 3, 2 pi over 3. So the phase shift, the C value, is 2 pi over 3. My horizontal phase shift is 2 pi over 3 units to the right? So this red graph, to end on this black graph, I'd move it 2 pi over 3 units to the right. Now that we have all of this, we could figure out our equation. So y is equal to the a value, which is 3, cosine b value, which is 1/2. I want my c value to be positive, so this would be x minus 2 pi over 3, because I want it to move to the right. And then my midline goes at the end, which is -2. All right, if you understood that, now we're going to do this one, which is more of a standard of excellence because it involves one further step. So the step is this underwent a reflection. So what you say to yourself is a is less than 0. Instead of 3, it's going to be -3. So when we have a reflection, two things are going to be affected, my a value and my c value. So my new equation is going to be this 3 becomes -3, cos, the 1/2 stays, my shift will change, and -2, that will stay. Okay, we need to figure out what the shift is. And it just, like I said, it takes practice in order to be able to do this. So please imagine this is your original graph. And the original graph underwent a stretch. So I stretched it by 3, so it underwent the stretch. Now I have to reflect it. So before I could do my translation, I must reflect this guy. So this graph here, I need to reflect this graph. So you need to visualize this graph reflected. Okay, so this is what it would look like. Not all of it reflected for whatever reason, but that's fine. Okay, so now remember that with a coast graph, what I want you to look at, with the sine graph, we're looking at the midline and what the transformation was. With the coast graph, we are looking at the peak. So this is after the reflection, and then it needs to move over there, right? Or I could look at this one. I could look at this point down here and it needs to move over here. We would get the exact same value no matter which peak I choose. So if I choose, let's say up here, and I say, okay, that's after my reflection. Now let's undergo the translation. Each box is worth pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So 4 pi over 3 to the left. If I was to go from this point to this point, let's check. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So what my phase shift is my phase shift is 4 pi over 3 units left. That means that my C value is negative 4 pi over 3. That means that this would be x plus 4 pi over 3. If you understand this, I'm still going to do the last class example, but if you understand this, you could now do the standard of excellence questions. So what I had assigned in your homework originally was I said, when you do this guy, you want to do A is greater than 0. Now, do the standard of excellence. So see if you could figure out what the thing after the reflection. Okay, I'm going to end with this class example here. So we're going to be looking at the A, B, C, and D parameters of either a sine or cos graph, and we're going to look at which parameters affect the domain, the range, the amplitude, the period, and the zeros. So the first thing, again, I'm going to draw a standard sine graph, which would be this graph here, starts at 0, max is 1, min is negative 1. It doesn't matter what parameters you do to sine, the domain of sine never changes because this goes forever to the right and forever to the left. So the domain is always going to be of our sine or cos graphs xer. So that means that no parameters affect the domain. The range is definitely affected. So let's say I took y is equal to the sine of x, which I have right here. And let's say I said, please add 3 to that. What you would be getting is you would be getting a midline at 3. So 1, 2, 3. This would be your midline. And now your graph would look like this. And if I'm not changing my amplitude is still 1. My maximum's going up to 4, and my minimum's going, my minimum would be at 2. Right? So if the midline is at 3 and my amplitude doesn't change, what I hope you're seeing is that the range will change if I change the midline, right? So the range will change if I affect the midline or if I change the midline. So my D parameter affects my range, and so does my amplitude, right? The amplitude. So if I change the amplitude to 5, that's going to stretch it. It's going to affect the range. Okay, the parameter that affects your amplitude is only your A value. The parameter that affects your period is your B value. What affects the zeros? So in order to deal with zeros, I tell students, think about mapping. When we map, zeros is your x-intercepts. So what parameters affect your x-intercept? X over b plus C. So therefore, your B parameter affects your zeros, your C parameter affects your zeros, and the last parameter that would actually affect zeros that students might not think about is your D parameter, your midline. And I'll show you why. In this example here, y is equal to sine x plus 3. If I said, we'll graph it, this is what your graph would look like. What are your zeros? There are no zeros in this graph. So the zeros is going to be affected by the midline as well. Okay, as long as the midline is not 0, it would affect the zeros. Okay, B and C are more theory questions and they're application questions. These are really, really good exam questions. State the maximum and minimum values of the function in terms of A, B, C, and D. So here's what I tell students to think of. I want you to quickly sketch a graph. So draw yourself a Cartesian plane. I want you to have the midline of the graph to be 2, and I want the amplitude to be 3. So just do a quick sketch of this graph. So start with your midline. They want a midline, I want a midline of 2. Then if I said I want an amplitude of 3, that means that from 2, 1, 2, 3, my amplitude needs to be 3. If it was a sine graph, I would start at 0. This would have an amplitude of 3 because it's always measured from my midline. And then I would have to go down 3 as well. So down 3 would be 1, 2, 3. So down 3, it would look like this. Okay, so based on this, here's what I want you to do. See if you could answer what's the max of this graph and what's the min of this graph, if I give you an A value and a D value. So looking at this picture, the maximum of this graph is 5. That's the max. And the minimum of this graph is -1. How could you figure out a maximum of any graph using your A value and your D value? How you would do it is the maximum is always going to be whatever your D value is plus your A value. So think about it. My D value is 2 and my A value is 3. That gives me a maximum of 5. So this is what you would use to figure out the maximum of any graph. The minimum of any graph using my A and my D value is you would take your midline and you would subtract A. This would give you your formula for your minimum value on any graph. Let's apply it. My D value was 2 and my A value was 3. 2 minus 3 is -1. That is my minimum. So A plus D or D plus A will always give you the maximum of any graph, and the minimum of any graph would be D minus A. Okay, so it's really difficult to figure this out unless you're able to pick like a midline, pick an amplitude, graph it, and then you could figure this out. Okay, this graph here, we're only looking at the range. So what do I need to know? What is range affected by? If we went back up here, range is affected by. So all I care about in here is this D value of -4, which is my midline, and my A value, which is 3, which is my amplitude. That's all that's going to affect my range. So I'm just going to sketch a sine graph with a midline at -4 and an amplitude at 3. And then I'll be able to get the range of this function. So midline of -4, -1, -2, -3, -4. That would be your midline. I need to have an amplitude of 3. So the amplitude, I'm going to go up 1, 2, 3. The amplitude would go up to there. And then I also have to go 3 in the other direction. 1, 2, 3. So my maximum, you guys, I hope you can see this, is -1. And my minimum is -1, -2, 3, 4, 5, 6. This guy's -7. So my range of this graph in interval notation, the biggest y value is -1, the smallest y value is -7. If I was doing the range in set builder notation, y is such that y is less than or equal to -1, greater than or equal to -7, comma y-e-r. And that would be the range of your graph. These are all of the questions that you need to do. Again, I say do a is greater than 0. You must also be able to do for your unit exam a is less than 0.